Thanks everyone for coming. I just want to say that I'm giving this presentation on behalf of Jeffrey He, who is the PI for this project. So thanks to him and for all he did. So I just want to go to the next. So I just want to start by talking about what we mean by residual malaria transmission. So the definition for us is that the transmission that persists once universal coverage of ITNs, LLINs, and or maximal IRS coverage has been achieved. So we wanted, the aim of this study was to try to investigate the magnitude of this transmission and the contributing factors in these three ecological niches. You can see here the village, the farms, and the forest. And this is along the Thai-Myanmar border and in central Vietnam. So here you can see the malaria prevalence in the different study areas. Very similar Very similar in Vietnam and in Thailand, but you can see in Thailand it's 100% Vivax, whereas in Vietnam it's majority falciparum. And we know that these relapse Vivax cases in Vietnam have a 59% chance of having parasitemia for 4 months or longer. And that persistent, largely asymptomatic Vivax and falciparum infections are common in many areas of the low seasonal malaria transmission. And infections with low-density parasitemias can develop into much higher density infections at a later time, which are likely to sustain this residual transmission. Here you can see, this is a better map. You can see here this is the border on the Myanmar side and the Thai side. And each one of these red dots are individually GPS tracked points worn by 37 farmers and forest goers in Thailand and 70 in Vietnam. The pattern of the mobility of these falciparum cases is characterized by a short to medium range distance, about 7 to 15 kilometers one way, and its direction is affected by the village of origin. Here you can see this is so this is about where and when the outdoor transmission occurred along the Thai-Myanmar border. So here you can see this is for Thailand, both in Sun Ai village, which was a kind of modern electrified village with good health services. And you often had the Karen coming and going across the border, which also could affect how effective the malaria program is in this area. You had hamlets, which were further away from the village. And then you had folks who slept in farm huts near to the forest. The sporozoid positive mosquito was found here outdoors in the early morning hours in the forest area. The entomological infection rate was roughly 1 infected bite per person per month. And so considerable variation in biting times of minimus between ecological sites was found. And you can see that approximately 1/10 of the bites occurred an hour prior to sunrise or after sunset for all 3 primary vectors. And however, this proportion could be higher if biting occurred between 6 a.m. and 5 p.m. when we weren't doing our collections, as we're unable to measure during that time. But for people moving through the forest from site to site, foraging for mushrooms or honey or looking for certain trees or whatever they are doing, you could imagine that a much larger proportion of bites might occur during the day, making interventions like ivermectin and topical repellents more relevant. And you can also see that while in the village they had only minimus, both in the hamlet and the farm hut, they had other species here. Right here you can see a map of where the different types of species were found, and that in the areas in the forest you had a lot more minimus, and areas closer to populations that had a lot of maculatus. And here you can see the site of where we found the sporozoid-infected mosquito. So here this is the same thing but for Vietnam, and you can see that it occurs, a lot of biting occurs between 7 p.m. and 4 a.m., and that higher transmission happened in Vietnam than in Thailand. Here we have 3 infected mosquitoes that we found, both here at 7 o'clock and in the middle of the night, midnight, and at 4. Okay. Here you have a picture of the GPS tracker that we used to put onto the folks who were going into the forest, and we could track where they were sleeping so we could go back and collect samples in those sites. And here, this is about the all-night biting rates. And we can see that while all 3 of these sites, both inside the farm hut, outside the farm hut, and in the forest, had relatively similar biting rates, but this may be because these farm huts are fairly open air, and therefore you have similar similar ability of the mosquitoes to come and go as if you were sleeping in a hammock or something in the forest. And here's a map of the different collections. You can see that here in the city areas or in the village areas, you had a lot of different species, while in the forest, you had a majority dirus. And here's the stars where we found sporozoid-infected mosquitoes. One had 2. So this slide just kind of gives you a bit of information about the different sites where in Thailand, where these are the 2 sites where we just recently worked, but also some data from 2013 in Cambodia and some data from 2010 in Vietnam. And here you can see that residual malaria transmission is the transmission that remains after universal coverage of long-lasting nets has been achieved. And this slide shows that the universal coverage of LLNs has not yet been achieved in all these study sites, and therefore not all of the malaria cases could be seen as attributed to ongoing malaria transmission. For example, there was not enough LLNs that had been distributed to cover each family member, and the LLNs provided were not sized for family beds. You can also see that there was a lot of bites here during the time that people were not yet sleeping. This slide shows how the indoor exposure was to human vectors. To humans from the vectors. You can see here that for the village and hamlet populations, this is a village and this is a hamlet, that in Suan Ai, the indoor exposure to anopheline bites was higher compared to those outside for people not under the protection of ITNs, 93% to 88%. And for the users of ITNs, the proportion of exposure to Anopheles bites that occurred indoors, or by IN here, was dropped from 33% to 33%. 33% in Paman and 45% in Suan Ai. And in Suan Ai village, the PIS here remained the same as PIN because very little indoor biting occurred outside of the sleeping hours. However, the proportion of exposure that occurred indoors increased from 33% to 67% in Paman because there was both early evening biting and later morning biting indoors when people were no longer sleeping and were outside the house. If you look at the 2 boxes in the upper panel here, you can see that where there was relatively high access and usage of ITNs, there was still poor fabric integrity, which may affect the residual malaria transmission despite high net access. ownership, and use. The substandard net maintenance and treatment was prevalent, and villagers used damaged nets, both in Thailand and Vietnam. In the lower panel here, you can see that there was limited to no use of mosquito nets in farms or forest sites. And this was because families did not have spare nets to take with them to their farm huts, or nets were too cumbersome to carry. Or some of them said they felt like it was not possible to use nets in the farm or the forest environment. So here is a slide that kind of goes over the differences between the two countries. And you can see here that some that are in red are the ones that are similar, and the ones in black are the ones that are a bit different. So for disease epidemiology, they were rather similar, although Thailand was predominantly vivax, while Vietnam was predominantly falciparum. The biting frequency was low in both villages, although in Thailand they didn't have not much biting at all in the village, and higher biting in the farm huts in the forest in both areas. For biting behavior, we weren't able to collect that in Vietnam, so we're not quite sure. But in vector composition, you see mostly minimus in Thailand and mostly dirus in Vietnam. Well, in Thailand, you get 6 different species in the main village. In Vietnam, you had 11 different species in the village. And for access, both of them had low use in the forest and farm huts, while they had high coverage in the villages. And for human exposure, we weren't able to collect that in Vietnam either. So just some conclusions here. You can see that you can see that for LLANs or IRS, we reached the limit of effectiveness despite high coverage, at least at the village level, and that we think that there's additional or repurposed tools which could complement the ITNs, and they must be considered if malaria elimination is to be successful and for the MMPs to escape this vicious circle of poverty and ill health. You can also see that here we suggested some additional tools for personal protection for this pre-bedtime and wake-up time when they were outside of their sleeping areas that we found still quite a lot of bites. Also some additional tools for nighttime hours on farms or in the forest where people didn't have much use of nets. And next steps, we think maybe we need to start thinking about modeling transmission in these sites and testing new vector control tools, thinking about intervention studies, how to better quantify this residual transmission, and recording the life of these forest workers or farmers in different settings to understand what type of behaviors might change the way that they use these vector control tools. And lastly, I just want to acknowledge and say thank you to the donors from WHO TDR and to the partners here in Mahidol, in NIMPE and in QMIR, and to all the collaborators. And that's it. So if you have